Right, Shivish? Let's start. All right, so today we want to take a look at our application of differentiation, and then we have integration to finish up, right? Yeah. You're going to TV now. All right, so today we want to take a look at our application of differentiation, and then we have integration. Right. So let's take a look at the application of differentiation there. Right? One of them that we didn't get to do last week. But we didn't do any applications last week. And then we have integration to do. Right? I wouldn't get to do as much past papers as I normally want to do on integration. So I'll do them. I'll do a lecture. Crash course. The last 2 days, let's say a little longer. Right? So we are practicing there. All right, so one of the applications that we need to know for differentiation is for stationary points. Right? We need to remember a few things about stationary points. The first and one of the more popular ones is to identify a maximum point. Right? To identify a maximum point. And then we also have to identify minimum points. Right? These two we should know already. This one here, of course, we know that d2y dx squared is less than 0. This one here, we know this occurs when d2y dx squared is more than 0. But we could also use a first derivative test as well. This function here, right? From here to the stationary point. Is this function increasing or is it decreasing? Increasing, right? So you can see that dy dx here is more than 0 here, up till here, right? And on the next side, dy dx is less than 0. So the derivative test for a maximum point is if the first derivative goes from more than to less than. That's okay? So if you have a value here, let's call this value b. If you plug in x is equal to a and you get more than 0, and if you plug in x is equal to c and you get less than 0, then you have a maximum point. Okay? So if your first derivative goes from more than to less than, you have a maximum. If your first derivative, on the other hand, let's call this point x equal to b. If your first derivative goes from less than, when x is equal to a, to more than, when x is equal to c, if it goes from less than to more than, you have a minimum point. That's okay? That's all. So all these things you might remember from Form 5. Might. And then new one. What is here? Some stationary points look like this. ABC. Yes. Right? ABC. ABC. Right? Here now, what is here? There's a special stationary point, so the function increasing, when it reaches here, it's not going to decrease. It's going to continue to increase. This stationary point here, together with the other way around, it's decreasing. Right? It decreasing and it continues to decrease. These 2 points here, right? These 2 points here are called points of inflection. How is identify them? Well, one of the ways to identify them is if the second differential is equal to 0. But it is a real name test, right? because even when you identify the second differential to be 0, you still have to come back to the first derivative test. So you have to check and see if before x is equal to b, let's say you choose x as a, if dy dx is more than 0 here and dy dx more than 0 here when x is c. So when you plug in a again, x is dy dx is more than 0. When you plug in c, you get more than 0. So no sign change, point of inflection. Or on the other hand, if you have dy dx is less than 0, when x is equal to a, and you have dy dx is less than 0, when x is equal to c, no sign change, you have point of inflection. Okay? So if the sign's not changing for the first differential, inflection. If the sign's changing, then it's maximum. All right? So those are the rules. Ready? Right, and so? All right, good. Well done. Take a picture and pass it. All right, so I'm going to give you one here. Right? This question is a little long, but they're not challenging, right? That's a little bit long sometimes. X cubed minus 3x squared minus 24x plus 9. Right. So they want us to, oh, I didn't write it, but they want us to find the stationary points and write the nature. All right. So they want the nature and they want us to find these stationary points. That's okay. So the first thing we do is we find the first differential. Right. So stationary points occur when dy dx is 0. So the first thing we do is we find the stationary points. So we differentiate first. All right. So we differentiate first. And the second thing we do is we say that stationary points occur when dy dx or the first differential is 0. So make this equal to 0. Right? Make that equal to 0 and then solve for x. Tell me what you get. What you get here? You calculate from what you get. Sorry? Minus 2 and 4. Right? So minus 2, 4. All right, so take a look here. We're going to determine, I'm going to use first derivative test because we don't know if those points are points of inflection. So I'm going to use first derivative test and check and see if it's max and min, right? I ignoring second derivative test. So let's try the first derivative test one time. So I'm going to use right? As I said, I'm going to ignore second derivative. For now, I'm just going straight to first derivative. So let's check out x is minus 2, right? Let's pick a value more than x is minus 2, but remember, you don't want to go into the boundary 4, right? So just picture this in your mind. So you want to pick values around minus 2, but you don't want to go all the way down here because it's the next stationary point here. So you're allowed to pick values here between any value around here, around minus 2, more than minus 2 or less than minus 2. So let's pick 0 and minus 3. So let's pick a value bigger and let's pick a value smaller. The reason we're doing this is we want to see if there's a sign change in dy dx. No, don't matter. Right? In this case, it don't matter. But suppose these were boundaries. Suppose these were your stationary points, then yes, you want to pick values close to here. Okay? But 4 quite down here. So we can pick anything here. I just pick in 0 and I pick in minus 3. Okay? And for 4, I'll pick 1 and probably 5. Okay? You want to see how the function behave in there. Right? And for 4, I said I'll pick 5 and I'll pick 1. Okay? So our objective now is just to check the sign. Check the sign for f prime x. Of course, when it's minus 2, we know f prime x is 0. When it's 4, f prime x is 0. So let's see. When it's minus 3, put minus 3 in here again, positive 9. 9 by 3 is 27. 27 plus 18 minus 24, again more than 0. Check it from now, please. When you plug in 0, again, f prime, right? Again, f prime x will be less than 0. Look at that. So plug in minus 3 in here, plug in 0 in here. I got more than and less than. Yeah, right? So if the function increasing then starts to decrease, what kind of function is that? Maximum. So therefore, x equal to -2 is a maximum. Ideally, you should find the y value as well, right? How about here now? How about here? Let's plug in 1. Plug in 1 in the function. You'll get 3 minus 6 minus 24. So you're getting less than 0. Then plug in 5. Help me out here now. Right? That is 25 by 3. That is 75. More than 0. So again, less than to more than. Therefore is a what? Are you okay with that? Of course, you didn't have to do this because you could have just used second differential. Right? But just showing you how I setting it up for the next one. Should do all the time. Like if you get 3 points, 2 points generally max on them. Once you go beyond 2, one of them might be. Right? But what you could also do is find the second differential. Right? What you could also do is find the second differential, and if you get equal to 0, then you come back here. All right? But this is the hardest thing. That's picking the value. Some people sometimes the points good and they pick bad values. Right? But generally, when you have 2 points, you can only go up and down. Marks on it. Oh, all right, let me do it one time. Right? So the second derivative test, you can do it one time. I was just showing you this one because I wanted to give you 2 examples, right? But the second derivative test, you differentiate this and you'll get 6x minus 6. Then plug in x is -2. More than likely, you will get less than 0. Therefore, it's a max. Come here now. Second derivative is 6x minus 6. Plug in x is 4. You'll get more than 0. Therefore, it's a minimum. Or if you get equal to 0, point of inflection, then you come and do this. That's okay? Let's try one now. This one here, I want you to do second differential and then choose the point. Online, are you okay there? Find the nature of each stationary point, right? Huh? So you never see me in class? No, I never have. That's the next year of class. No. So Friday. For the one. Huh? You want to start with Friday? If I want to start you in the class, yeah. So like, if I'm not ready. Oh, yeah. Without line something. Get out in the line something. Yeah, this time up. Right. So whatever it is. Ready? Oh yeah. Are we done here? This up is full up already. I think so. I got it before. Let me show the sign up. I guess. Yeah, please. Oh. Last time said you did one zipper. You did two this. I like that. Right? Lots. Right, so you should have your first differential by now, and you will get minus x cubed minus 6x squared. Right? And then remember your stationary points occur when f prime x is 0. So it's minus 4x cubed minus 6x squared is 0. When you solve, what you got? X is what? X is? Negative 3 on 2, 0 on. That's all? Yeah. Right? Work it out now. Which one is max and which one is min? Yeah. Right, so find the second differential. Find your second differential. The second differential is minus 12x squared minus 12x, right? And then we're going to start here. Let's plug in x is minus 3 on 2. X is minus 3 on 2, so f double prime is minus 12 by minus 3 on 2 squared minus 12. How much is that? -9. So therefore, less than 0. Therefore, it's a maximum point. Right? Please remember to find the y value. Find the y value as well, right? Plug in -3 and 2 here and get the y value. Now, when x is 0, we have a problem. Right? So when x is 0, we have a little problem. We choose f double prime 0 giving us 0. So therefore, a point of inflection exists. Right? We have to confirm it. Right? We have to confirm it. Right? So you're taking when x is 0, you're taking, what's the value you choose here? -1. Right. You can choose -1. Can you choose -2? Can you choose -2? No, because it goes beyond that point there, right? Beyond -3 and 2. Okay? Right? And just check it out quick. This is the first derivative test. Huh? This is a first derivative test. Right? So the first derivative here, we know the first derivative here is equal to 0. Plug in -1. When you plug in -1, I get in a minus, eh? Less than 0, right? Yeah. Plug in 1 now, again, less than 0 again. That's okay? Yeah? Less than, no sign change, therefore point of inflection. That's okay? So this graph probably will look like this. It went up to a maximum, and then you had a point of inflection somewhere. It went up to a maximum at 3 and 2, and then when it reached 0, it decreased and then continued to decrease. Probably something like that. I like how this looks. Hold on. So you probably have your point of inflection here. Point of inflection here, sorry, at 0. And your maximum here at -3 and 2. So it probably looks something like that. Went up to a maximum inflection. Okay? Question didn't ask you. I want to make sure you understand. Are you okay with this? Allocate point of inflection. And this basically what you have to be able to handle. All right? Take a function, see if it max or min. If not, check and see if it's point of inflection. Everybody okay with this? Just like Form 5 except for this thing. All right? Right, let's do one more application of differentiation, rates of change. Right? Yeah, rates of change. Oh, wait, before I do that, oh yes. One thing I keep forgetting to do because they expected to know this, right? Add this into last week notes. Right? How to differentiate 1 on x. That's not. Right? This is not really on your syllabus of plenty questions. You gotta know the integral of this. Right? So it's important that we learn to differentiate this. All right? So here's the rule. Here's the rule, right? If I were to ask you, add this to the list of differentials from last week, right? If I ask you to differentiate this, suppose I ask you to differentiate, if I ask you to differentiate, what man, let's write this now. I write the wrong thing that's now. If I ask you to differentiate ln x, right? The differential of ln x is 1 on x, right? Generally, if I ask you to differentiate something that looks like this, ln. Anybody remember why I put in modulus signs here? Huh? Because we could only find one of a positive, right? So if I ask you to differentiate ln f of x is your denominator and your numerator is the differential of it. Okay? So if I ask you to differentiate ln x is the denominator and your numerator is the differential of x. All right? That's it. X here, differential of this here. You know that, kill it? Next one. All right, let's just do a few of those now. Right, the reason I have to show you this is that when we do differential equations, you will see a couple of questions in that form. All right, let's just do 3 examples in this, right? It's not a popular thing, but you see a differential equation, there's a few of them where you have to learn that. Please differentiate this ln 3x. Differentiate ln 3x plus 1. Sorry, 3 squared plus 1. And last one, maybe another tricks. Differentiate ln cos x. All right, let's try those there. Huh? It's not something that once and you get two. All right, try and differentiate each one of those there. Oh yeah. Ready? Yeah, we done? Yeah. How are you? Nicola, hurry up now. 1 over 3x. Online, work them out, yeah? Work them out. All you please remember to sign up crash course, huh? I'm going to advertise this weekend. Huh? Well, for no, all you I'm good to think physics for that. But I want to make sure all you have a space first. Right, and all you have until the 15th to pay. I pay the chapter.
Yes.
Huh? Not like that. We finished that like no, not for come first. No, done with that time. Right, so what we have here, 3x in your denominator and your numerator is the differential of this, which is 3. Right, 3 will cancel and you'll get 1 on it. Right, here, your denominator is 3x squared plus 1 and your numerator is the differential of this, which is 6x. Here, your differential, your denominator is cos x and your numerator is the differential of cos x, which is minus 1. Right? Well, which is minus 10, right? Nice. So I wanted to go over that because I forgot to do that last week. All right, so next thing you want to do quickly, some rates are changed. We'll do it 1 or 2 rates are changed. Right? But the main focus is integration after. Right, online, are you okay there? Oh yeah, the angle, sorry. Yeah, the angle there. All right, last thing here you want to take a look at. We want to take a look at the last thing you want to look at is rates of change. Right? Just a quick reminder, Shibish. Right? When they say rate of change of y, what are you talking about? Shibish? When they say rate of change of y, what does that mean? Huh? It means dy dt, Shibish. Right? It means dy dt. Right? You want to see how y changes with respect to t. But how do you find these things? Huh? So how you just find dy dt if they give it the x, t, and you use chain rule, right? So one side is up ty, the next side is up, and the variable goes here. So you find dx, dx. Right? Same thing if you have dv, dt, and so on, right? If you had volume. Right? If you had the rate of change of volume. Here would have been dv, here would have been dt, and sometimes height. So you put dh here, dh here. Yeah, you have height on them. All right. So rates of change we use chain rule to find any unknown things, right? Let's do a few now. Yeah. I think that's work out easier now. Right. Let's try this here. A spherical balloon. A spherical balloon is being inflated. A spherical balloon is being inflated. a spherical balloon is being inflated. First up, the radius of the balloon is increasing. The radius of the balloon is increasing. The radius of the balloon is increasing at a rate of 0.1 centimeters per second. The radius of the balloon is increasing at 0.1 centimeters per second. That's the important part, right? 0.1 centimeters per second. So first up, find the rate of increase. Find the rate of increase. Find the rate of increase of the volume of the balloon, when its radius is 5 centimeters. When its radius is 5 centimeters. Right? And for number 1, they gave you the volume. Right? The volume is 4/3 pi r cubed. Right. Just take a little reread again. What else they gave you? They gave you dr dt. Nice. That was what, 0.1, right? What else they gave you? dv dt, dv dh by dh. And it said when r is 4, right? Yeah. And what they asked us for? Huh? R is 5, sorry. What they asked us for? Of what? A volume, right? So they asked for dv dt. So what would the formula be for dv dt? dv dr multiplied by dr dt. And we already have dr dt. So it's just to find dv dr. So we need an equation with v and r. So we're going to use this here. We're going to differentiate that. What's the differential of dv dr? 4 pi r squared. How do I get when r is 5? Substitute r is 5. Remember when this was at? 5 squared is 25, by 4 is 100. What you do next? Substitute and you get to go 100 pi multiplied by 21. So 10 pi centimeter cubed per second. Copy down. Let's go again. Nah, what is that? Nothing. All right, let's try one here a little bit harder. All right, got it. So let's take a look at this here. It's a little bit tricky. That's all. I like this one though because this one I used to bring a long time. In the older years. Try this in. Yeah, it's a little tricky. That's all I did it. A little bit harder for you to get it from. Oh, you get the answer for this one. So constructor square. Yes, square. So it's directly sine. Chibish. What? All right. It's not a little bit hard. No. Take a little bit. Right? So they give you a funnel, right? The funnel, a funnel filled with water is in the shape of an inverted circular cone with a base of 8 centimeters. Okay. Just 8 by the next circle. Oh, shucks, did the wrong question. All right, ignore diagram. The diagram is on next question. Yeah, the diagram was on next question. Hold on. This question actually had no diagram. Yep. Hold on. All right, sorry. So let's take a look at this instead. Same question, but you have to figure out diagram, kill it. Right? So a funnel filled with water is in the shape of an inverted circular cone, right? Of base with 8 centimeters, height 15. Water is leaking away through a small hole in the vertex at a constant rate of 2 centimeters per second. Let V be the volume of the water in the funnel, and H is the depth of the water in the funnel. Express V in terms of H. How we drawing that in the first place? Same thing that on top, right? You have a port, right? Put in the radius, right? Water going in at a constant rate. Oh, sorry, it's not leaking. The water coming out. Water coming out at 2 centimeters per second. The radius is 8. I'm just going to fix this piece of the diagram. This is 8 centimeters. right, is inverted and has a height of the entire height of the cone is 15 centimeters. Right? And it was filled with water, right? It was filled with water. And water leaking out of that radius. So that 2 centimeter cube per second is what? Right? dV over dt. Right? So we have that. But we need to get V in terms of H. How are you doing that?
Yes.
That's why you found up a volume. What's the volume of a cone? Say that again? 1/3 pi r squared by h. Not for this. Not for this. But to be honest, I don't know they will get rid of this. Like they will give me that formula to put it for a code. So express V in terms of H, but you don't want R. So what to do? What to do? Yeah, it's substitute for R. Correct. One like this? Oh, yeah. Copy it down, and see what you can do. I want to go on the board and do it, right? You want the rate of change of depth. Depth of what? Of H, no? H. All right. So if you look here, right, so V is equal to what? V is equal to 1/3 pi, R is saying 8, right? 8 squared H. So the equation we have here, how much is 8 squared? That's 64 on 3. 64 on 3H. Something out with it. Part B now, they want the rate of change of height, right? And that's what they want? The rate of change of depth. So that will be DH, sorry. So here is DH, here is DT, here will be DV, here will be DV. Right? We already know DVDH. That's this right here. We already know DVDH. Sorry, DVDT. Right? That's the rate of change with respect to time, right? So we know this value, so we need to get this. So since V is equal to 64 pi on 3H, we can make H a subject of the formula. H is equal to 3V all over 64 pi. So therefore, dVdH, sorry, I meant dH dV, right? So if I differentiate this now, I'll get this. So if I differentiate H with respect to V, I'll end up with 3 on 64 pi. Right? So therefore, we get 3 on 64 pi multiplied by 2. So I get 6 over 64 pi. This is centimeters per second. No, some not making sense. That's not, I feel I use the wrong equation. I feel I use the wrong thing for V. That's now let's just take a little read. Right? A funnel filled with water is in the shape of an inverted circular cone of base radius 8, height 15. Water is leaking away through a small hole in the vortex. So let V be the volume in the funnel at H, the depth of the water in the funnel. All right. Here's what happened here then. Right? They want in part B, they want when H is equal to 10. So what that means is that we have to have H in our equation, but when I differentiate of H left, right, something went wrong here. Because what is saying here in our solution, this saying here that the height will always be this, regardless. And V is the original volume. So this saying that the height will always be this. So what I should have done here, online, and just going back to what I have on board, right? So everything here okay. Everything up until here okay. But they want an equation for volume that will vary with depth. So therefore, I need to find a way to get an equation for R. All right. So, so I had to find a way to get. So, for example, here. Right. So here we have volume at a particular depth H and radius R. So how do I get that equation? So we have V, you want to see how A changing, how to get an equation for R. All right, so here's how we can do. Since what will be the original volume? What will be the original volume? Remember, V would have been same equation, 1/3 pi R squared H. V would have been 1/3 by pi by R, which is 8, by H, which is 15. This will give us the original volume, right? How much is this? 325. Oh, 325. Yeah? 305 centimeter cube. So if I were to say that pick it up, look, it's now just give up parity. This is have a little tricks in it too. Huh? But I want different. All right, yeah. All right, so here's what you're supposed to do. All right. So what you're supposed to do was the same thing I was saying earlier, right? We needed to get an equation in terms of R. All right. So we need to get an equation for R and then substitute R there. So here's what we have initially. Initially, we have a cone. You have 8, you have a little right angle triangle there. You've seen it? And this angle here, as the radius changes, will the angle change? No, the angle won't change. So this angle is what? Tan theta is equal to opposite over adjacent. Okay on that? Yeah, opposite over adjacent. So here now, tan theta is what? Also opposite over adjacent. So it means that this equal to this. So it means that R on H is equal to 8 on 15, which means that R, carry the H here, is 8H over 15. That's okay? Now we know what R is. So as H changes, we know what R is. So now we come back here and we can say that V is equal to, if I get move this out, 16 squared 15 by 3. So it will be pi by H cubed. What is this here? Pi on 15 squared by 1/2. Right, so we're online. So we're doing something like that to get R, right? What's this here?
64.
Boy, just multiply by target of us now. 64 and 225 by 3. We can substitute, but we'll do that later on. What? 64 and 675. So therefore, let's find dVdt and then find dVdh. dVdh, sorry, DBDH is what? 3 here. So that'll be 3 by 64. So that 3 would have cancelled with this 3. So I shall leave it there. So that would be 64 over 225 by pi h squared. You see what we end up here. Now we can substitute h is 10. That's okay. So watch. The reason I didn't put h is the reason I didn't substitute h as 10, then I wouldn't get this equation I wanted. All right, I wouldn't get the equation. I will get the equation. I will get the h value. I'll get the v value when h is 10. I don't want that. I want this equation here, part E. Sure? Huh? So when I substitute, yeah, I'll get dh dt and then I will flip it over. Right? How much is that? So dv dh is equal to 100 by this 6400 over 225 pi. So it means that dh dv, flip it over, 225 over 6400 pi. And then you multiply 225 6400 pi multiplied by dv dt, which is 2. Right? So what is that? 450 over 6400 pi. That's okay? So you needed this relationship. You needed this relationship in order to find R to get the equation for part E. All right? I made a mistake initially because I get a constant. Right? This is what you're supposed to get because H, the volume will change as H changes. Any questions online? You want to penetrate now, a little bit there. Yeah, it is easier than this. This one here is similar to what you might get in SBA. Right? So in SBA, you might get something like that. Right? So they give you a problem like that and your ice cream cone leaking. You want to know how long it will last. Okay. All right, yeah. Sorry about that. I kind of didn't think that word. So after this, wait, I can give you all a break now, 5 minutes.
5 minutes.
Right? So these are the things that you need to get in differentiation. All right? This is a long one. Online, are you okay with this here? Azaria probably will listen. I'm going to go to somebody else. Ishmael, Bob, are you okay there? All right, so generally, if you see a question like this, there is a relationship that you have to get. All right, I just didn't read it. This is the video we're talking about, not the whole board. The volume as it changes. All right, so that's the other differentiation. All right, questions that you would see in the except for last year, which I find was kind of hard. All the other differentiations simple. Right, last year I found was a tricky. So this year it might be a challenge. 2023 was a harder differentiation than the other years. Right? Now we're going to focus on integration. All right? I'll give you a little break. I will give you, was 5 minutes, so it's 4 minutes now. starting back at 6:35.
So what are you 15 minutes last week?
No, that was last week. Because I had all our integration, I had to do integration by substitution, and
That easy.
I still have to do it.
We're just going up.
And I had to do differential equations. Most important. You guarantee to see that. I go online. You have a 9-minute break. Probably 8 minutes now. Right, then we begin integration. As I said, I will do a lot more practice during the crash course, right? A lot We gotta do again. Next one. All right, let's go again. Integration time. Online, you reach back. Azaria, you reach back. Azaria. All right, just start back, Azaria. Anybody online there? All right, there's some people there. All right, so let's run over integration, right? And then we'll take a look at the applications, right? All right, ready? All right, so let's take a look at how to integrate again. So the integral of ax to the power of n is what? What is do? Shirish, what is integrate? Basic integration. Huh? So it will be ax add 1 to the power n divide by the new power plus c. Right? And whatever integrals that is, indefinite, right? So if I gave you the integral between b and a of f of x, that will be integrate like normal. When you integrate, that will be capital F. So it will be capital F of a minus, sorry, capital F of b minus f of b. So integrate like normal, and then plug in b and a, no plus c. That's okay. Nice. So just for you to remember that. One quick rule for you to remember from Form 5. Suppose I were to do something like this. The integral between b and a of f of x. But instead of b to a, of course, b is more than a, right? B is more than e. What do you think would happen if I had put in a and then b in the integral? What do you think would happen? You'll get negative value. Right? You'll get negative value. Right? Nice little rule to remember. If instead of putting b to a, put a to b, you'll get negative value. All right? Next integral to remember. The integral of a constant k is what? With respect to x. Kx. Right? Plus c. What's the integral of ax plus b to the power n? Right? So you write back ax plus b, you add 1 to the power, you divide by that new power, and you divide by the differential of the bracket. Right? Dot dx. Right? While we're here, I could show you integration by substitution one time. Right? So integration by substitution, a technique that we can also use to integrate things like this. All right, so watch this here. So just say I said, okay, well, let u equal to ax plus b. Suppose I let u equal to that. Then here we'll have the integral of u to the n dot dx. But I have a big problem here, right? I want to integrate something with respect to x, but there's no x here. So I get rid of this. That's okay? What we're going to do, Sarah? What I'm going to do, Sarah, I'm going to differentiate this. And I will get du dx is equal to e. That's okay? So therefore, dx is what? Dx will be du all over e. That makes sense? Multiply and then bring the a here. So here I can do now. What I could do now is I could say, well, dx is equal to du on a. So I could write du on a here. That's okay? You guys? I could pull the 1 on a outside, not the a, 1 on a. So I'll get 1 on a by the integral of u to the n dot du. What's the integral of this now? What's the integral of this? U to the n plus 1 over n plus 1 plus. That's okay? And what is u? U is ax plus b. So now I'll end up with 1 on a by ax plus b to the n plus 1 all over n plus 1 plus. This is the same as this. It's longer, but this is your first example with integration by substitution. Okay? Two things you have to remember. When you make a substitution, whatever letter you use, it don't matter. You have to integrate with respect to that letter. Okay? You choose R or P or whatever, you have to integrate with respect to that variable that you choose. Right? So therefore, to get that, you will have to differentiate the substitution that you make and then make the x subject at the formula. Substitute and negative. All right? Since we're here, try this one now. Right? Please note that this is integration by substitution. Right? Try a nice example here. 4x minus 1 all cubed. Don't use the shortcut, right? Use integration by substitution. Just to get it practice. Pardon me? How long does this? For this one, no. For this too easy. This one really easy, but they are more challenging once I'll show you that one. Where you will have to do that. Oh, you have to try that there. I think so. Yeah, it will come up. You're done?
Yeah.
So you'll end up with u is equal to 4x minus 1. Du dx is equal to 4. So now when you substitute, you'll get the integral of u cubed minus du over 4. That's a 4 here. So I'll put another quarter. And here you will get u to the power 4 over 4 plus c. So I got 1 on 16. I got 1 on 16 by 4x minus 1 to the power of 4. Anybody get that? Yeah. Online? Are you okay there? Are you get that there? Samira, Kalia, are you okay? Right, let's make it slightly harder. Try this, Samira. Nice. Try this here, Samira. Find the integral. Right. Find the integral of where hard? No. Now here. X by square root x. Right, 2x minus 1. Sorry, 2x squared. Yeah? This is 2x squared minus 1 all to the power 3. 2x squared minus 1 all to the power 3. Same thing here, integration by substitution. Yeah. I was going to show you how. Right. We're asking you tonight. We're pointing it. Right next up. And that's 60. The 160. We'll draw that line here. But not by side. This point here. Point right here. Right with me? Okay. So that's what you want to get at. Focus on this line. This line is my degrees here. Draw off your whole line, sir. Right, find the integral of x by 2x squared minus 1 all cubed. Integration by substitution, right? right? I didn't give you the substitution of what you use as substitution. Generally part of the bracket, right? So let u equal to 2x squared minus 4. Right? You're saying, let's see how it looks. Should we get that? All right. Let's see what you end up with. Let's see what you end up with, right? Right, Shivish, what's the differential of this? 4x. So therefore, dx is what? du over 4x. And then you make a substitution. So you'll get the integral of x. We have a slight problem here. By u cube dot du on 4x. Hello, see that? Yeah? What will happen with the x's? Cancel off. And you'll get the integral of u cube dot du. What you will do to do cancel off? No, it's not right outside the variable. You want to rearrange and solve for x. Right? So if it doesn't cancel off, then you'll have to come back here and make x a subject and make a substitution. Right? When you integrate this, you will get 1/3. Right? You will get 1/4 by 1/3 u. Sorry. I'll leave all the quarter on the outside. Yeah. So it's 1 on 4, 4 plus. So this is 1 on 16, u to the 4 plus c. This is 1 on 16, 2x squared minus 1 to the 4th plus. All right. So that's the principle behind integration by substitution. If you have limits, if you have limits, you have to just substitute for the limits, right? You can find new limits here and then put it in after. put it in before if you want, you can work this out. I'm gonna give you one with limits, right? Like online, you all can message the answer for this one, right? Azaria, you can message the answer for this one. Azaria, respond. Azaria, good. Good.
Where is that?
I don't know.
26.
Somebody could have some message Azaria there to come back to class. Azaria. All right. So I'll give you a hardest one here. This is 6 marks. It's a pass paper. You know hardest. But that's for Azaria. Mother. Shivish. What call your mother? Do this, remember this? No limits, a normal one. No limits. Right, because of the 4, you want to change letters up to you, right? I don't want to mix up my 4. Okay, look at that. Right, I'm gonna tell your mother what time to look at the video. She will see. I'll let you online here. Watch. 6 marks earlier. Finish. All right. Finish. See what you're going to. Right. See how you can even differentiate anything. You find du dx. Du dx is what? Du dx is 4x cubed. You differentiate that. So therefore, dx is equal to dx is equal to du over 4x cubed. So when you substitute, we're going to get a slight problem. X to the fourth plus 2 is u cubed by 4x to the 7 by du over 4x cubed. What will happen here? Well, not everything. This will cancel with this, and you'll end up with, so you'll end up with u cubed by x to the 4. Right? We still can't integrate this as yet because we have with respect to u, but we still have x. What do I do here? Right. Come back up here now, and I can see that x to the 4th is u minus 2. X to the 4th is u minus 2. Right? So taking up x to the 4th, and I'm going to write u cubed, x to the 4th is u minus 2 dot d. Okay, then you multiply it out, you'll get u to the 4th minus 2u cubed dot d. Now we have everything with respect to u, we can go ahead and integrate. Right, this is the integral of 2u to the, sorry, that's a minus sign there. Right, so that would be u to the 5 on 5 minus 2u to the 4th on 4 plus, and now what u is? U is x squared plus 2 all to the 5. 2 over 4 is a half. X squared plus 2 to the 4. Okay, leave it like that. Can't do much again. You can factor out anything. You still have the plus c here. Right? If you want to factor out x squared plus 4, that's okay. Right? But you have product and you still have the plus. That was 2018, right? Are you okay with us? Nivesh? Sure? Where you get lost? Where you follow what I did here? Because I had x to the 4th, I make a substitution, right? So like whenever you replace dx, but you still have a term here with x, you have to go back to the first equation. Right? Yeah, you will need to. Right? Because there's no product rule for integration as yet. Right? You do something for integration, but chance. You need to. Kind of like product rule. Yeah? All right. Let's continue the integration. Huh? No, we've done integration. Yeah. So do you understand? Yeah. So you come back with it. Any questions online? Tyra? Are you okay? Which one? Yeah, it's sorry. I check the phone and then live. That's it, you know. Check the phone, I just show like what's up. It's like all right. So let's take a look at integral of traits. And then do some applications, right? And do not first study first application. Yeah, solve the differential equation of the work. Guarantee the speed up. Somebody write this up. All right, so let's take a look at some tricks quickly. So the rules that we need to remember, if I ask you to integrate cos ax plus b, of course, you can do substitution here, that u equal to this and integrate it, right? But the integral of this is 1 on e sine ax plus b, right? The integral of sine ax plus b is minus 1 on a cos ax plus b plus c. Next one you have to learn is the integral of sec squared. The integral of sec squared ax plus b is equal to 1 on a tan ax plus b, right? So three basic integrals that you need to remember, right? Integral of cos sine, integral of sine minus cos, integral of sec squared tan. Integral of tan. A solution of law limits. Much easier. Questions you'll get a different level of maturity. Questions easy one. Well, so you see like how you will work for 6 marks, double that to the same for less. Plenty work. It's easier, but it's plenty work. Okay? Easy. Right. How will you integrate something like this? It's a quick example. Right? If I ask you to integrate sec x dot tan x, how you will integrate something like this? Try it. Okay. Try it. Try the integral of sec tan x. Do your thing. Do your thing. Let me see what your thing gets. Sketch. Can I share it again at that point? Ready?
Yeah.
What again? Then do what? What's the difference of time? Right, just remember 1 plus tan squared is sec squared, right? Might be helpful, it might be helpful. Oh, yeah, forgive me. So can you remember? Yeah. How are you doing? Finished? Right, any ideas online? Azaria, since you reached back, any ideas? How do we integrate something like this? So obviously you're seeing sec, you have a few options earlier. Right? So you could say sec squared x is 1 plus, sorry, sec x is the square root of 1 plus tan squared. Correct? So you'll end up with the integral of the square root of 1 plus tan squared x dot tan x. This is one option. Huh? I saw this one after. I'm going to try this one here first. Right? But our next option is to make a substitution. And then simplify it. Right? But let's see what will happen here. So if I do this here and I say, well, let u equal to, what to let u equal to? 1 plus tan squared. If I let u equal to 1 plus tan squared x, you find that hard to differentiate? Yeah. So let me try u equals to tan x. Right? If I let u equal to tan x, I will get du dx equals to sec squared x. Right? So I'll get the integral of the square root of, remember 1 plus tan squared is what? Sec squared, right? So I will get 1 plus, next would have been next, right? Anyway, so when you reach here, you'll get dx is equal to du on sec squared, right? So when you reach here, I want to show you something, right? I have a few options. Right? I'm going to replace tan x with u, and I'm going to replace dx with du over sec squared. Right? Remember, 1 plus tan squared is what? Sec squared, right? So I'll end up with the integral of sec x over sec squared x dot u dot d. And 1 on sec. Kind of working out nice. All right, I like this one. I saw that one after. Just checking to see if that could have popped. So let's simplify this a little bit. Sec is 1 on cos, tan is sine on cos. Right? This is the integral of sine x over cos squared x dot dx. Cos squared x is what?
1 plus sine.
So cos squared x is equal to 1 minus sine squared x. Right? And if we let u equal to sine x, you'll get du dx. You'll get du dx to be cos x. So it means that dx is du on cos x. So we end up with the integral of u over 1 minus u squared dot du on cos x. All right, just take this for now. Not getting that much to right? The only method of getting this integration by pass, and that's unit 2. Right? So ignore that. Just write this rule down. Right? Turn it from my example into a rule. Right? The integral of sec tan x is equal to sec x. Something I probably. All right. So these are some of the integrals that we need to know for traits, right? And after this, we need to know a few applications. Right? We need to know a few applications of integration. TikTok. Right? So the first application is to find area. So if I give you an integral between A and B, the area here, right? The area there is given by the integral between B and A of f of x with respect to x, right? As if y is equal to f of x, right? Suppose it was the other way around now, because as opposed to add max, we need to know this as well. Suppose you have a function looking like this. Right here is C and D, and you want to get the area here, and you have y is equal to f of x. Then the area is equal to the integral between C and D of what you have to do is make y the subject of this formula. So it's f of y dot dy. All right. Third thing we need to remember about integrals. If you integrate here, right? This integral will be positive, here it's negative, here positive. All right? And if this is the limits between A and B of f of x, if you have to find the integral between A and B of f of x, what do? Since the area underneath here or the integral underneath here is negative, you can put modulus or put a minus sign in front. All right? So if you have the area below the x-axis, right? Just some quick rules to remember. Next thing that we need to remember is that if you have to integrate a function, right? And you rotate that function between A and B. If you rotate the function about the x-axis, you would get a shape that we could find the volume of, right? And the volume of that shape is the integral between B and A by pi, the square dy, and differentiate, integrate it. Right. Oh, sorry. Yeah. Sorry, one. Sorry. Right? And if it would, this is about the y-axis, right? About the x-axis. If it were about the y-axis, it'll be the integral between the limits, but instead, you make x the subject and you integrate with respect to y. All right. So some of these things you know already from Form 5, right? But there's a new thing that we're going to look at. And you technically cannot do it already in Form 5 technically, right? Where you solve first order differential equations, right? We're not really solving second order, only first order. And the technique that we're going to use to solve first order equations is to use separation of variables. So our first order is where you only have dy dx. Second order is where you have d2y dx squared. All right? So as a quick example, if I give you something like this, dy dx is equal to f of x over g of y. Watch it. I'll write it as now. How do you solve this? When they say solve, they want you to get an equation in terms of y. You already remember this from Form 5? dy dx is equal to 3x squared plus 2, let's see. And you have to define for y. They give you the gradient function, you would integrate here, and you will get y is equal to 3x cubed on 3 plus 2x plus c. Right. That is the same thing that we're going to do now. Right? Right. So basically, all we're going to do here is carry dx on this side and then integrate. So you separate the variables. You put all the y's on one side, you put all the x on one side. So if I give you a function like this, where you have something in x and something in y, you bring the y on this side. So you will get g of y dot dy and you bring the dx on this side. f of x dot dx. So you're integrating here and you're integrating here. That's it, make y subject of the formula. All right, so we're gonna take a look more at these. I'm not doing that today. Right? I will do questions like all these in crash course. All right, I'll do plenty of these. Plenty of the old years have these, but the more recent years, they start bringing this all the time now. I'll check what that integral is. Now it's like that. Right. How are we doing that? How are we doing something like this? So you'll see a function with x and a function with y, right? So you're bringing the y on this side and you're bringing the x on this side. So you write separation of variables. Bring the y on this side. You'll get y squared is equal to you'll get y squared dy is equal to x cubed dx. Then you can integrate here. You're integrating y with respect to y, right? So this will be y cubed on 3, right? And integrate x cubed, you'll get x to the 4th on 4. Watch this here. Sometimes people just wonder what to do with the constants, right? When you integrate here, you're supposed to have a constant, right? Let's call it C1. Are you okay with this? Sarah, you okay with this and this? Integrate this to get this, integrate this to get this. And I separate the variables, right? So you have one here and you have one here. But you would recognize its solutions, so I only write in one constant, right? When I bring C1 across here, that will get C2 minus C1, which is a constant. So does it make a difference if I just write this? I'll get the same constant K here. So you do have to write C1 here and then C2 here. Just write one constant. Because in the end, you'll still get one constant. All right? No, I don't want. I just put k, right? And then when you reach here now, make y the subject of the formula. So carry across the 3 and then cube root everything. So multiply everything by 3, you will get 3x to the 4th on 4 plus 3k, and then carry across the cube, you get cube root everything. Okay? Online, are you okay there? You're almost done. Let's do it now a little bit again. As are we paying attention now? Now we are going again. Laptop recharging again. I mean, one that technically, yes. Right, but you can't just put k here. Right? You can't just put k here. You have to put 3k here. Because when you make y, if you were to solve for k here, you will get one value. But if you solve for k here, you'll get different value. Right? Afterwards, if you want. Right? But here is where you do what I was telling you. Not in the making y the subject of the formula part. Because you will end up getting a different solution from somebody else. Right? Here's where you can put one variable. Huh? Always make y the subject. The objective is to solve. When this is solved by differential, you're trying to make back y the subject. Right? So you don't you're not putting the form y as an express. You just make it y the subject. Try one here from right. Sometimes they would say, well, solve the first order differential given that when x is 1, y is 0. Right? The purpose of these 2 points is to plug in y is 1, y is 0, and solve for the constant. Okay? Those are called particular solutions. This here is your general solution. It means that any value k will work. Right? But when they get a specific value, k does for the particular solution. Right now, this is a general solution. Okay, copy down. Solve that there. Any particular solution. Now, square minus sinus some square. So you don't forget this already. This is the right? You have to find anybody sneaks from the right. See which two numbers will give you a C when you multiply and then those number right? That's not very something. Try to this way again. Bueno, check se vivió la bueno, average totalmente. Oye, feel it. That's fast. Do it like normal. One of those values is X and one of those values is Y. Right? So the pi on 4 is X and the pi on 2 is the Y bar. Hurry up. Already do. All right. Let's see what you got here. Right. So first thing, carry across here. Carry across the X on this side. Integrate. The integral of cos is what? The integral of sine is plus c. Right? Carry across your sine and you'll get y is equal to sine. Actually, let's find c first. So what it's saying is that when I put pi on 4 into y, again this. So that's the x value, that's the corresponding y value. Now, so that is sine, right? What it's saying is that if I have a function in terms of y, and I substitute this x value here into y, I'll get this value. So there's the x and there's the y value. If I were to substitute this value, pi on 4, into y, I will get pi on 2. So this is the x value, this is the y value. Okay? So that cos pi on 2 is equal to minus cos pi on 4. Sin pi on 2 is 1, cos pi on 4 is 1 on root 2. So C is 1 plus 1 on root 2. Okay? And then you'll end up with sin y is equal to minus cos x. What's 1 plus 1 on root 2? Simplify. Okay? Alright, I'll write it like that. 2 plus root 2 all over 2. Right? But don't leave your answer like that, right? Make y the subject. Sin inverse minus cos x plus 2 plus root 2. Finally, what? Right? This is your particular solution. Please remember, this is a general solution. This is a particular solution. Particular solution when x is this and y is this. All right? Copy them. Last one. This time, I am not giving you the differential. You have to make it up. All right? So I'll give you some information and you'll figure it out. Try that in. Last one next class. Right, but I'm hurry up. Try that there. Oh yeah, last one. Oh yeah, Paul, yeah. Last one. Shibish. Right, so take a little green and see if you can develop that equation. It's the last thing we done earlier.
So can you give us a head quiz?
No, go ahead. Slope is what? Which is? Right, I'll give you a help there. dy over dx is equal to the product of the x component and the reciprocal of y. What is the reciprocal of y, Shivish? Shivish? What is the reciprocal of y? Reciprocal of y is 1 on x. Shivish, the reciprocal of y is 1 on y. Right? So it's equal, what you did, right? The slope is equal to the product of the x and the reciprocal of y. What do you have there?
Y squared over 2 equals x.
So you have a first order differential equation.
Yeah.
Now solve it fast.
So,
Finish already?
yeah. Yeah, y squared over 2 is equal to x squared over 2.
Right? So you're solving the first order.
Yeah, that was good.
You solve dy dx is equal to x and y. Solve that fast. Are you okay with that one line? So Mira Ranju, are you okay with that? Francis? You'll follow how I got the dy dx x and y? That was the first one. The second one, like,
Why the first one like that?
so the first and second one that worked like this. So the difference. So you end up with y dy is equal to x dx. So again, y squared on 2 is equal to x squared on 2 plus c. And then solve for c.
Yeah. Yes.
C is how much?
4.
Okay with that? Let's follow and on. So technically, that's the end of the. I didn't do questions on the area, right? I'll do that in crash course, right? Right, but that's the end of your module 2. Differentiation, integration, and limits. What looks like the hardest?
No, that's everything.
No, what the hardest in module 2?
Limits.
Limits? All right. All right.
Yeah.
Module 2 might be tricky.
No.
Module 1?